Hey guys, it's Miss Landry, and today we're going to talk about variables and variables in experimental design. So you're going to learn all about designing an experiment, which I think is awesome. So enjoy. Let's just make sure that we are here. Okay, the first thing I want you to know is the independent variable. This is the one where you, as the scientist, are going to make changes. So I could do something with plants, and if I'm giving them different amounts of water, that's my independent variable. If I'm giving them different amounts of fertilizer, that would be my independent variable. You only want one independent variable ever, because if you have more than one, you're going to be confused about which one it is that is causing the effect. So I have an example on here of an experiment. You guys know I love Cheetos. So I wanted to see if eating Cheetos increased hip circumference. So I broke the class up as follows. So you can see this here with this group. I have 5 groups, and each day they eat different amounts of Cheetos. So group 1 ate no Cheetos. Group 2 ate 20 Cheetos a day. Group 3 ate 40, so on and so forth. And I would do this for a while and then hopefully see if it made a difference. So by doing this, you can see that I'm changing the number of Cheetos that these people are eating. So if you look right here, number of Cheetos, I've changed this as the scientist. So that is my independent variable. Kind of makes sense, and hopefully you get that. So next, let me get off of this highlighter because it's a little bit annoying. Okay. So the dependent variable is the one that you will measure as the scientist. So this is the one that when you made your hypothesis, which we'll learn about next, you are hoping is going to be affected by the independent variable. So in this case, I am looking at hip circumference as a percent change. And so I'm going to measure this. So the dependent variable is always measured, always. So if you notice this hip circumference, I'm measuring it. So that is going to be let me go back. Sorry, guys, hang on. That is going to be my dependent variable, this hip circumference. So remember, the number of Cheetos they ate per day is the independent variable. The amount of hip circumference change as a percent is the dependent variable because it depends on what I do with the independent variable. So there's another set of variables called constant variables or controlled with an ED at the end, LED, variables. This is where the art kind of comes into designing experiments. The better you are at understanding constant variables, the better and stronger your experiment will be. So this is really important. Basically, these are variables that you're going to keep the same for all groups. We do that because what if there's something else in there in the experiment that could possibly cause a change in the dependent variable? Then we won't know, was it the independent or was it this other factor? Like I said, these are very important. Okay, so remember that a controlled or constant variable is something that we keep the same for the experimental and the control group so that it's not affecting the outcome. So for example, in our Cheeto example, right, remember that the independent variable was the number of Cheetos eaten per day. So that's kind of like what I, as the scientist, am changing to see if it affects the dependent variable, which was the change in hip circumference. So now let's think about what we can keep constant. So I'm going to want to keep what they eat outside of the Cheetos, right? So their diet, possibly their age, how much exercise they get, because that could certainly affect hip circumference, how much sleep they get, the type of Cheetos, so crunchy versus puffy, the mass of Cheetos, because each number of Cheeto might be different. I want you to really kind of think about some more and in your journal kind of write down some ideas that you might have for some controlled variables for this experiment. The last variable I want you to know are control variables, not controlled with an ED on the end, but just control. These are used to compare the experimental group to a group that you know the outcome. So for example, we have 2 types of controls, right? We have a positive control and we have a negative control. In both cases, we know the outcome, right? And if they, sorry, that was my cats. But if they don't work, so if my result is not what I expected for the controls, you really can't trust your results in your experiment. So let's take a look at what I mean by that. Okay. So here's an example of some data that I got for this Cheeto experiment. Okay, oh, I don't know what just happened to it. There we go. So group 1 that got 0 Cheetos, their hip circumference increased by 12%. So that means that this group right here, which is my control group, my negative control, they still had an increase in hip circumference. And take a look, all of the other group that ate the Cheetos did not have an increase in hip circumference that was larger than this negative control. If this experiment had kind of gone the way that I had expected it to, I would have expected that those not eating Cheetos would have had less of a hip circumference change than all the other groups. And really, it should be like a positive relationship, right? Just the more Cheetos, the bigger your hip circumference becomes. So in this case, I would look at this data and say, well, I think I might have been incorrect in my hypothesis, because it doesn't look like, if Cheetos were the only thing that I'm changing, it doesn't look like that is affecting the hip circumference. For positive controls, a lot of times we use those in diagnostic testing. And an example of that would be, like, if you look at this picture, hang on, it's coming. There we go. So I'm testing some serum, let's say somebody's blood or spit or something for like a virus, let's say. So I'm looking for well, we could even just say it's like COVID, right? So I would actually put into this positive test a sample that I know is positive. So if I'm testing for COVID, the sample I put into this is positive for COVID. Here's my negative control, and I'm going to highlight this so we can really see it. So here's my positive. So if the sample that I'm going to test is positive, it should turn red just like this. Here's my negative sample. So this is a sample that I put into the test that I know does not have COVID. And then here's my patient. So I have the patient sample. So I can compare them to the positive and the negative control and say what result they are. So obviously in this case, that person did not have COVID. The test was negative. If it had turned red, it would be positive. But think just for a minute, what would happen if my positive did not turn red? If I know that this sample has COVID and it does not show a positive test, I cannot definitively say that this is negative. It could be that the test isn't working. So controls are really important, and that's something that we will talk about a lot in class. Let me try and get rid of this thing. I'll just leave it. So the last thing I want to talk about is, sometimes you'll hear in studies about different groups. So we have two different types of groups. We have experimental group and we have control groups. Experimental groups are the ones that receive the differences in the independent variable. So if I'm doing like a drug trial, like I'm trying a new drug and it's for headaches, so the experimental group will get different doses of the headache medicine or just get the headache medicine. You can have a lot of experimental groups depending on if you're looking at different amounts of stuff, and you're going to compare your results from the experimental groups to the control group. So a control group does not receive the independent variable. They sometimes, especially in drug trials, they'll receive a placebo, which looks just like the drug, but it actually is a sugar pill. Those are used to compare to the experimental groups. Remember that control groups can be either positive or negative. So if we look at our experiment again, you see we have two different groups. The first group, this one right here, is actually the control group. And in this case, it's a negative control because I did not give them Cheetos. And then the rest of the groups here, 2 through 5, that all got different amounts of Cheetos, are my experimental group. And what I would do in the end is compare the hip circumference change to my negative control to see if there was a result. So I hope that helps understand variables. Make sure you have your notes in your journal for checking in class, and let me know if you have any questions. Thanks, guys.